In the last problem, we're going to look at the case where the mass is changing. Until now, we've assumed that the mass is constant, but in the case of rockets, because we're burning fuel, the mass is changing, and there's a something called the rate of mass, and that rate of mass, or rate of change in mass, if you want, is what we know from our calculus as the change in mass per change in time. And we're told that we lose about 1 over 1/20th of whatever our original mass is every second. And since we're losing this, we will put a negative value there, so this becomes negative initial mass over 120 per second. And now we can think of the acceleration as velocity per unit mass times this rate of change in mass. The book tells you why this is the case. If you're not 100% sure, you can read that, but this is basically F equals ma again. F being the velocity times the change in mass rate. Ma is the A times M initial, and then we divide to get A isolated. Again, this will need a negative in front of it because this is a decreasing relationship. It's the opposite. The bigger the mass is, the less it's going to accelerate, and so on. So this is negative. We're told that it has a relative speed of 2400 meters per second. We don't know what the original mass is. We don't need it, actually, because our rate of change for the mass is given in terms of MO. And if we do this, we get about 20 meters per second squared, which are units of acceleration. So that tells us that this formula that we used is okay, which is a form of F equals ma again. Part B says find the speed at the end of the time of the 90 seconds if it keeps continuing going this way. Velocity final equals velocity initial plus the relative speed times the natural log of the mass over remaining mass. So the ratio of the masses. At the beginning of the 90 seconds, the rocket is not moving, so this is meters, 0 meters per second. We know it's going at 24 meters per second. And then the natural log of, we're told that we have now M is a fourth of what the original mass was. So this becomes 2400 meters per second times natural log of 4, which is the same as 3327 meters per second.